Hey there! On the SAT hard module, nonlinear equations are completely designed to drain your clock if you rely purely on the traditional methods. Today, we are tackling 3 brutal problems, but we are skipping the algebra completely. We are doing this 100% in Desmos. The third question is a massive conceptual trap, but I am going to show you how the calculator makes the answer visually obvious in seconds. Let's pull up the first one and get to work. Minus 25x square minus 10x plus c equal to 0. In the given equation, c is a constant. The equation has exactly one solution. So whenever you see exactly one solution, please head on to Desmos and let's type this equation there. Why are we typing this on Desmos? Because that's exactly what you'll be doing on the test day. Minus 25x square minus 10x plus c. Add the slider and please make this slider from minus 100 to plus 100. Now let's see what do we have here. So we are expecting a parabola to see here, and what is the question asking us to do? It's asking us to find the value of c so that this particular equation has exactly one solution. So this particular equation, this parabola should be touching. This parabola should be just touching the x-axis. Here it is cutting the x-axis at 2 points. We don't want that. We want this parabola to touch the x-axis at exactly 1 point. That is when we have exactly one solution to this particular equation, and for what value of c this equation touches the x-axis. That's what he is asking you. So let's move around and see where that happens. I think we got the answer. Let's see if that is it. Let's zoom in a little bit more to make sure that it is touching at exactly 1 point. Yes, that is what it is. So at c equal to minus 1 is the answer. So c equal to minus 1, this particular equation touches the exact x-axis at exactly 1 point. So that is the solution of this equation. So let's head on to the next question. Let's read the question. In the xy plane, the graph of the equation intersects the line y equal to c, again exactly 1 point. So when you see exactly 1 point, please go to Desmos, and we need to type on the Desmos this equation, also this equation, and then see both this parabola and the line should exactly intersect at 1 point. So that is at that what particular point that is happening, for that value of c we are trying to find out. So for what value of c these two equations exactly touch at 1 point, that's what we are interested in. So let's go to Desmos. I'll make this a little bit cleaner. Let's erase the past memories so they don't interfere with our present. Let's type these two equations. First one is y equals minus x square plus 11x minus 50. So did we get any parabola here? No. Let's zoom out. Yes, we have a parabola there. Let's type the next equation. Y equal to c is the next equation. Y equals c. Now here please pay attention. Desmos is acting a little bit stubborn. It's not giving us the slider for c. So what do? You go to the next line, type down x equal to 1. Now once again set the default settings to minus 100 to 100, and now let's play around with c to see the green parabola and the violet line touch exactly at 1 point. So let's see when that is happening. Let's zoom in. Zoom in a little bit to see that they are exactly touching. No, they are not touching, they are intersecting. So let's change this a little bit. Oh no. Okay, let us type it. Let's type minus 19. No. Minus 19.5. No. Let's type minus 18. No. So minus 19.5, it's not giving us the answer. minus 20, where is it? Where is the equation? No, it has gone somewhere else. So minus, sorry, it's not minus 20. So minus 20, we are not getting the answer. Minus 19 as well, we are not getting the answer. So the answer is somewhere in between minus 19 and minus 20. So let's try minus 19.5. No, it's not happening. Let's try minus 19.25. It's not happening. So let's type minus 19.75. Yes, I think this is the answer. Let's zoom in. Yes, that's the answer. Minus 19.75. Let's head on to the options. Shall we write it down? C equal to minus 19.75. Let's head on to Desmos. Okay, we have the options in fractional form. So let's go back to Desmos and try to convert minus 19.75 into fractional form. So how do we do that? Just simply type minus 19.75 and type this fractional option that you are seeing here. So there we go. C equal to minus 79/4. That means option A is our answer. So let's go to the next question. Let's read the question. X square minus 26x plus c equal to 0. So here we have a quadratic equation, a parabola. In the given equation, c is a constant. So it's telling you c is a constant. The equation has no real solutions. Now please pay attention here. No real solutions. So this particular equation should not be intersecting the x-axis, or it should not touch the x-axis. And he has given you one more condition. C should be greater than n. What is the least possible value of n? He's asking you. So he's not asking you the value of c, he's asking you the value of n. And what is the condition on n? It should be least possible value of n. So let's go to Desmos. Let's erase the past memories. Please make sure that you do this particular task. Please make sure that none of the past remains when you're typing the Desmos. Otherwise, those past values can interfere with your present ones. So let's type this one. X square minus 26x plus c. Let's type till there. And then let's add slider to c once again. Make this from 100 to 100. And let's zoom out and see where are we getting that parabola. Yes, we have a parabola here. And what are we interested in? We want this particular equation, x square minus 26x plus c, to not have any real solutions. So this particular parabola should not touch the x-axis. That's what he has asked. So let's make sure that this particular parabola is not touching the x-axis. Let's play around with c and let's see what's going to happen. No. So let's increase the value of c to 200 and see. Yes, I think this is there. So if you see here, now I want your attention here. Please pay attention. C value, if I take my 170, this particular parabola is not touching the x-axis. Correct? And that is what he has asked in the question. Let's try to see if 169 is 169, it is exactly touching the x-axis. Yes, so 169, it has exactly one solution, this particular equation, and at c greater than 169, it has no real solutions. So the question that he has asked you is, the equation has no solutions, that's the condition. The equation has no solutions, that's the condition. What is the least possible value of n? He's asking you the value of n. So the point is, what should be the least value of n? If I take the value of n as 169, if I take the value of n as 169, then c should be greater than 169. That's what we are getting from here. C equal to 169, it has exactly one solution. We don't want that. So C has to be greater than 169 is understood. That is clear. He is asking you what is the least value of n. C is greater than n. That is the condition that is given. So n should be equal to 169. That gives us the answer. All right. So let's head back and quickly revise what we have done so far. We have started with this question. We have typed this exact equation and then we have obtained the value of c equal to -1. Here exactly one solution, please go to Desmos. Whenever you see again exactly one solution, exactly one point, please go on to Desmos. Here the only point is you have to convert your answer back into fractions. That's what we have done. And then for the last question of this video, what we have done, yes, this is a little bit tricky one. He has asked you, he has given the condition on C, but he has asked you the value of n. So that's the tricky part here. So C has to be greater than 169 according to the question. C has to be greater than 169. C has to be greater than 169 for it to have no real solutions, and n has to be equal to 169 because he has asked you the least possible value of n. So n has to be equal to 169. So I think we are clear so far with these three questions. And that is exactly why visual math wins on the digital side. When you leverage Desmos to do the heavy lifting, even the trickiest conceptual traps become guaranteed points. If this visual hack helped you out, hit the like button and subscribe to the channel for more test day strategies. And if you are ready for elite level math training to absolutely crush your target score, head over to bhargavacademy.com to see what we are building. Keep grinding and I'll see you in the next video. Bye bye.